Salts are formed in neutralization reactions between an acid and a base. Therefore, salts should exhibit neither acidic nor basic properties. Indeed, solution of many salts, such as sodium chloride, have neutral pH. But if we measure the pH of ammonium chloride, it turns out as acidic. In contrast, sodium acetate solution is alkaline. In today's lesson, you will discover the causes of this phenomenon. Salt hydrolysis is the reaction of an anion or a cation of a salt with water. Most salts completely ionize or completely dissociate in water. For example, sodium ethanoate, a salt, dissociates completely to form sodium cation and ethanoate anion. Let us study the process that takes place in an aqueous salt solution to characterize it as neutral, basic, or acidic. Salts from strong acid and strong bases consist of anions from strong acids, for example, chloride ions, nitrate, sulfate, and perchlorate ions. Cations from strong bases, for example, sodium ions, potassium, lithium, and calcium ions. These anions and cations do not react with water or does not undergo hydrolysis. For example, anions from strong acid such as chloride ions, nitrate ions, and sulfate ions are extremely weak bases which do not react with water. Similarly, cations from strong bases, for example, sodium ions, potassium ions, lithium, and calcium ions, are extremely weak acids which do not react with water. Let us look at an example of sodium chloride. Sodium chloride is a salt formed from strong acid, hydrochloric acid, and strong base, sodium hydroxide. The salt sodium chloride dissociates completely to form cations, sodium ion, and anions, chloride ions. Both sodium ions and chloride ions are not hydrolyzed by water because they are extremely a weak acid, sodium ion, and a weak base, chloride ions, which do not react with water. There is no production of extra hydrogen ions or hydroxide ions. Therefore, the salt solution of sodium chloride will be neutral with pH 7. This applies to all salts produced from strong acid and strong bases to be neutral with pH 7. Salts from strong acid and weak base consist of anions from strong acids and cation from weak base. Only cation from weak base undergoes hydrolysis. For example, let us look at ammonium chloride, a salt formed from a strong acid, hydrochloric acid, and a weak base, ammonia. Let us study the process that takes place in an aqueous solution of ammonium chloride. When added to water, the salt ammonium chloride undergoes complete dissociation into ammonium cations NH4+ and chloride anions Cl negative. The ammonium cation from the weak base ammonia behaves as a weak acid in an aqueous solution, donating protons in reaction with water. Thus, the concentration of hydrogen cations H3O+ increases, which makes the solution acidic. The two important equations that is needed to be shown is the dissociation of the salt into its anion and cation as shown in the first equation. The second equation shows that ammonium ion NH4+ acts as a Bronsted Lowry acid and donates a proton to water. Chloride ions Cl negative does not react with water. The production of hydronium ions from hydrolysis of ammonium ions causes the solution to be acidic. Therefore, the salt solution of ammonium chloride will be acidic with pH less than 7. As a conclusion, salts produced from strong acid and weak bases will be acidic with pH less than 7. Salts from weak acid and strong base consist of anions from weak acids and cations from strong base. Only anion from weak acids undergoes hydrolysis. Let us look at an example of sodium ethanoate salt, formed from a weak acid, ethanoic acid, and a strong base, sodium hydroxide, as shown in the equation. As you can see, there are two equations given here. The first equation shows the complete dissociation of the sodium ethanoate salt into sodium cation and ethanoate anion. The second equation shows that the ethanoate ion acts as a Bronsted Lowry base by accepting a proton from water. Sodium ion does not react with water. The production of hydroxide ions from hydrolysis of ethanoate ions causes the solution to be basic. Therefore, the salt solution of sodium ethanoate will be basic with pH more than 7. As a conclusion, salts produced from weak acid and strong base will be basic with pH more than 7. Let us conclude the types of salt. A neutral salt with pH equals to 7 is formed from a strong acid and a strong base, where the cation from strong base and anion from strong acid do not hydrolyze. An acidic salt with pH less than 7 is formed from a strong acid and a weak base. The cation from weak base hydrolyzes as an acid. And a basic salt pH more than 7 is formed from a weak acid and a strong base, where the anion from weak acid hydrolyzes as a base.